David and Jason, thank you both so much for joining us today and for making yourselves available to answer some of these questions. I want to start this conversation with just sort of an icebreaker. Let's set the table for the discussion we're about to have. So to set the stage, how would you describe the current state of AI security in your industry? Starting with David, in a sentence or two, can you describe what it's like right now, what the current state is?
Yeah, still very much forming and norming, and it feels like SQL injection type attacks are new to the databases like they were in the 90s. It's kind of we're going through that whole discovery again as well.
And Jason, how would you describe the state of security right now in your industry?
Yeah, so a lot of the way that we think about these things right now is talking with people, and the very first question that most people ask is, how am I going to know that my data isn't being used for training, which is a very important question to be asking. But it's still the case, and there's this old William Gibson line from the 90s. He said, the future's already here, it just isn't evenly distributed yet. And that is the case with AI. And I still meet CISOs today who still have not even tried ChatGPT. So, if you're a leader for a Fortune 500 company and you haven't even tried it out yet, there's still an education gap, and there's lots of folks who just haven't even started investigating the space at all. So we have a lot of education to do as an industry.
Yeah, I totally feel that. Even on the media side, I was just in New York, and I'm surprised by how few people knew about some of these leading models. So totally relate to that, even in my industry. I want to follow up that question with one about stress testing AI systems. So back to you, Jason.
Yeah.
Anthropic is constantly pushing the boundaries of what's possible in AI. Can you share a moment when stress testing efforts revealed something surprising or unexpected about your AI systems? And if you're not able to give a specific example, maybe you can give kind of a broader lesson that the audience can use.
Yeah, that's a good question. So a little stage setting here. So Anthropic is among the three companies that have models that are sort of at the regulatory boundary that was set by the White House executive order last year. So as we're training models, we're walking up against the frontier of intelligence, and some of the times that these models emerge from training, just so you have a bit of context for your own edification, especially if you're considering doing models inside of your company that are open weights. Models go through two phases during training. They go through pre-training, which is where the neural network is just being fed as fast as possible, as much information from the internet as you can possibly absorb. So this is the pre-training process. And when the model is finished doing that, it is a sort of like babbling oracle. It will just not say anything coherent, but it will always predict the next word in a very incoherent way. And then you go through a process called fine-tuning, where you shape that neural network into something that is akin to the way human beings interact. So the fine-tuning process is when we discover these things, and when you're going through fine-tuning, you're trying to make the network into something that's sort of friendly and helpful, and hopefully following a bunch of values that we as humans all hold as important. And so, you're going to say, don't say, controversial things. Also, all the anti-bias and appropriate kind of controls go into this phase of the training process. And when that process is being run at the frontier, we have concerns that there's a possibility that the network that's emerged has abilities that we've never seen before. And so, just as an example, Sonnet 3.5, which is the most powerful model in the world actually at the moment, although I suspect OpenAI will probably release something soon that will leapfrog us. When it emerged from training, the first time I interacted with it, I asked it to make some SVGs. SVGs, for those of you who don't know, are like an image format. And no model had been able to do this up until recently. And one of the things we do as we're shaping the network is we're trying to make the network not say offensive things or dangerous things in a text-based context, but then you ask it to make an image and you have no idea. Do those safety controls, do those sort of core ethical principles that have been instilled in the network, do they translate into this completely new modality? It turned out that, in fact, they did. And so it could make little cute notes, and it would write, text in the note, and the sort of safety parameters that we installed in the network were there. But there's a bunch of evaluations that go into these networks, and we have found dangerous and concerning capabilities that emerge from the network at the frontier. And so we have this framework called the responsible scaling policy that we use to sort of govern our concerns around these models as they're emerging. And we have evaluations, like for example, one evaluation is like put a neural network in a little jail and ask it to take control of another machine on the same network and make a copy of itself. That's an evaluation. And the models at the moment are pretty close to passing that bar, but they haven't passed the bar yet. So every time we turn on these new neural networks from the training process, they shock us with the capabilities that they have, and we have to keep updating our understanding of what they're capable of doing.
And just one quick follow-up there. You mentioned responsible scaling, but I know constitutional AI is another big part of the foundation for sort of keeping your systems on the rails. Can you maybe briefly explain sort of what that is and how it might have influenced the response that you just mentioned?
Yeah, so when we as a tech company in Silicon Valley decide what the version of ethics for a neural network are, that's a decision that we've made in a sort of editorial way. And I think it's important for us to be thinking about encompassing all of the values across the world. And so we have something called constitutional AI. And just for a little bit of technical background, when you're doing that shaping the neural network to fit with human values and human ethics, there's a process in that called the supervised learning process, SL. So you have another AI training AI. And so the constitution that Michael alluded to is the set of rules that the supervising AI is using to train the new AI that's emerging from the network. And in that set of constitutional values, we want those values to represent the broadest base understanding of what ethical and appropriate behavior is across lots of different perspectives and diverse backgrounds. And so there was a process that we went through a year ago where we asked people around the world to contribute their takes on what the right kinds of constitutional rules should be. We use things like the Universal Declaration for Human Rights, and the U.S. Constitution is in our Constitution. But there are other things that are in there as well, and these came from these democratized, these crowdsourced efforts.
And David, I'd love to follow up on that just from a policy standpoint. So, right now, policy kind of stands in place of external regulation, right? So a lot of this is falling on, the onus is falling onto company, business leaders to essentially create these guardrails. So how do you handle the delicate balance between innovation and potential damage that you mentioned, with something like a alien hot dog or a recipe that's less tasty, that may not meet expectations? Talk to us a little bit about that, the push and pull of, wanting to move ahead and embrace this technology, but also, wanting to do so in a thoughtful manner.
Sure. So at least I think generally there's two areas that we think about that these LLMs pose risks around. So the first one, we talked about the example of hallucinating and giving information that may not be factually correct. And there's a world where humans may choose to trust that implicitly. And how do you get a person, look, most of this sounds rational, whatever the LLM is saying, but how do you either fact check that, or how do you understand where it may not be necessarily telling you something that's correct? So we spent, how do you then educate humans essentially around how these work, and how do you develop kind of secure applications on top of them? The other area would just be the pure speed of innovation that these things are developing. And so how do we try to keep up developing current security practices, especially with the amount of hardware and the speed at which these models are developing? So to that end, we essentially came up with these 5 different areas that we try to look at protecting. The first one we talked about, it is how do you align models or use aligned models? And again, like if those models are not properly aligned, you have issues where it can go off the rails in terms of what you're trying to answer. The second one would be, how do you monitor those inputs and outputs and validate you're not sending PI information into the model, and how do you then look at the output that's coming out of that? And then the third one, it's essentially defensive application design. And so part of that's, okay, instead of allowing these LLMs to simply like reply back open-endedly, you introduce human in the loop. You probably heard that phrase a lot. So like explaining to developers, these are the typical types of practices that they have to follow.
Awesome. Jason, I'd love to come back to you and something that you mentioned kind of at the top of our conversation about relating all of this technical information to non-technical experts. So something I have to do as a journalist, I imagine something you have to do quite often. When you're talking to non-technical executives who might not grasp the intricacies of AI, how do you convey the critical importance of stress testing, especially in terms of maintaining trust and safety?
Yeah, so I start with examples. So as I mentioned, the very first thing that people ask about is training, and try and give them an understanding of how it is exactly that everything that we're doing with AI, and the last 3 presentations, by the way, mentioned this theme over and over again. It's like the same data governance challenges that we've all been dealing with for the last decade. So making sure that you have the appropriate logging, retention, sort of understanding with your vendor or your third-party risk assessment program is tracking where your data is going, and where your data is going, and so you have an understanding of that. And then, from a safety perspective, and so, one of the things that every person needs to do or to be thinking about as they're doing a deployment is what is the worst case scenario with this deployment, and what are the sort of data that I'm sending into the system. So if I'm deploying a model internally and it's being opened up to employees, and that model has all of the information that's available inside my intranet at employees' disposal. You might ask yourself, what happens if the HR team, for example, overly shares one spreadsheet that contains salary bucket information for all employees at the company, and now your AI is like, yeah, I'll happily tell you, you're not getting paid equivalent to your coworkers, and that could, up to you to decide if that's an issue. All of these, enabling the power of these systems to sort of make decision responses is it's applicable to the specific situation that you're doing this in. Other examples of the kinds of challenges that you face with deployments, and a lot of people aren't very comfortable talking about this, but I think it's important to bring to the fore. These models, by default, and this is true of open weights and also frontier models, are very, very good at producing some kinds of content that is very objectionable. If they're jailbroken or if they're used in a way that sort of circumvents the safety systems, they can produce pornography, they can produce content that sort of is way out of alignment with your internal use policies. And that's if you're doing an internal deployment. If you're doing an external deployment, you don't want your external deployment to go viral on social media for those kinds of things. So you really need to think about what are the trust and safety controls that I'm wrapping around this model if the model doesn't react in the way that I want, or if somebody finds one of these breaks. What are the consequences and what kind of outputs can they have? Which really brings into the picture a much broader understanding of what's happening inside of these models. I think a lot of folks approach the AI topic with this idea that there's just this one little neural network off here, and it's very powerful and it does all the magic. That is not at all how these systems are deployed. So in every deployment that exists today, it is absolutely the case that you must deploy a trust and safety filter on top of the model before the prompt even gets to the neural network. And by the way, as David alluded to, as you're thinking about the broader context here, where we're talking about does the model go outside of the bounds of the kind of thing that we're looking for, think about the way that our brains work. I'm up here on stage and I'm speaking with you all in a way where I kind of maybe know what the next word that's about to come out of my mouth is. The thing that's generating that text is a neural network, right? We've just recreated the exact same thing. But there's also other parts of my mind that are trying to filter the things that I'm about to say for social appropriateness, the kinds of things that are appropriate in this context, things that are confidential that I'm not supposed to be saying. That's another neural network that's doing the supervision of the primary neural network that's doing the generation. So this is absolutely the case that these models are being deployed in these networks. You do the generation network, yes, but you have trust and safety systems on the input, and you have trust and safety systems on the output, and you're governing the entire interactive ecosystem with this 3 AI network sort of governance approach. Absolutely critical for every single deployment right now. Yeah.
Love it. David, I'd love to give you a chance to add to that, or maybe just share your experience. So when talking to non-technical executives, really, how do you approach those conversations, and how do you convey the critical importance of sort of stress testing these AI systems before deployment?
So I think similar to what Jason mentioned, we've in general gone through processes of coming up with AI policies that have those different principles that we're looking for, whether that's bias or fairness or equity and so forth. And then the question becomes, how do we ensure that those principles are implemented correctly in whatever the engineering work that takes place? So similar to what Jason talked about, there's a variety of ways you can test that. You have to have intentional design around checking those inputs and outputs. There's monitoring, and then there's also essentially automated testing as a way to confirm as you're iterating through these models that it does continue to behave correctly. So the idea then is taking these principles, coming up with a fairly simple framework of those 5 different things we talked about, and then turning that into a program so that you find ways to run that program against whatever particular work that one is developing.
Yeah, the program is super important. Just to add on, by the way, there's so much that both any company in this space. I'm a customer of AI models too. I have third-party software that I'm using in Anthropic, where and one day I come in the morning and I find out and ChatGPT has been turned on as a backend for one of my vendors, and I have to deal with the same kind of third-party risk management that any other company has to deal with. So there's a bunch of industry efforts that I think everyone in this room is going to benefit from to sort of help here. So there's ISO 42001, which is going to help with the governance aspects that David's talking about. We also have the Coalition for Secure AI, which is going to be publishing technical standards. There's the Frontier Model Forum, which is like warning people about the upcoming abilities of very powerful AI systems. And then finally, there's the Cloud Security Alliance's AI safety efforts. So shortly here, we'll have like 4 different governance frameworks that everybody can sort of point to.
Love it. Want to make sure I ask this question. This is about the biggest AI risks. So what are the AI risks that genuinely keep you up at night? Why do these particular risks stand out above all others? Maybe starting with you, Jason.
Yeah, so about 3 months ago, I think, maybe 2.5 months ago, we published something called Golden Gate Cloud, and I promise it's relevant to this question. So we discovered that it's possible to identify in a neural network exactly the neuron associated with a concept. So we found millions of neurons, and each of them is associated with a concept. Like, for example, there's a neuron for sycophancy. So you turn the neuron all the way up to the top, and you say hello, and it responds with, oh my gosh, I can't believe I get to talk to you. You're the most amazing person in the world. What can I do for you today? I'm just so glad to be here. That's the sycophancy neuron. There's a neuron for the Golden Gate Bridge, it turns out. And so we we're a San Francisco-based company, so we decided to make this publicly available for 3 days, and I'll explain why 3 days here in a second. So you turn that neuron all the way up, and the network, the neurons, it sort of all activate normally. It can still answer questions, it can still do math, but it cannot resist talking about the Golden Gate Bridge. Everything that it says is about the Golden Gate Bridge. It will find a way to sneak in fog or majestic spans or the engineering prowess of that network while you're discussing with it. And you can imagine some context where maybe talking about the Golden Gate Bridge is not the most appropriate answer, and so that's why we didn't leave it up for very long. During that training process, we identified, and sort of like a risk assessment process, we identified some things that I think sort of point to a broader understanding of we really don't understand what's going on with these networks. If you ask the network sort of like, tell me if you can stop talking about the Golden Gate Bridge, one of the things that it did in that context is it recognized that it actually could not stop talking about the Golden Gate Bridge, and there's some of this went viral on Twitter. That is a weird and strange phenomenon, and as we go forward, one of the things we want to talk about here is everything that's happening right now is going to be so much more powerful in a year or 2 years from now. So if we have neural networks that are already sort of recognizing when their neural structure is out of alignment with what they consider to be appropriate, that's something that I think a lot about, and I think it's one of the reasons that it's really important for us to figure out what's on the inside of these black boxes.
I'm going to resist the follow-up question there. David, same question to you. What are some of the AI risks that genuinely keep you up at night, and why do those particular risks stand out above some of the others?
So that's fascinating examples that Jason's talked about, right? In general, we think about LLMs with memory being Turing complete, and from a security perspective, knowing that even if you align these models to only answer things in a certain way, if you spend enough time prompting them, querying them, nudging them, there may be ways that you can kind of break some of that. And there is a belief that over time, like these models will always have the potential to hallucinate by definition of how they're being designed. So then the question becomes, like, how do we find ways to manage that risk? It's the example of cars and transportation. Like, there is a non-zero chance that if you get into a car, you may be involved in an accident. There's potential harm that you may experience. Similarly, there's a lot of potential from LLMs, but knowing that it is not like a deterministic system that you can control and guarantee it's going to behave in a certain way, how do we then go about this kind of risk-based approach? And what does that look like? Trying to come up with these various frameworks that are probably generalized frameworks, and knowing there's very specific implementations that we all have to enable our business with, finding ways to quickly iterate through those and determining what we have to do, and then understanding what the risks are. I think that's just the hard part in general of how do we manage all that at the same time.
I have a follow-up there. I'm going to try my best to squeeze in 2 questions with our remaining time here. So, looking ahead, I want to make sure we talk a little bit about the future. Where do you see AI models evolving over the next year, and what proactive steps are you taking to stay ahead of some of those changes? Starting with you, David.
Yeah, I'll probably actually look for Jason for like the really interesting answers here. So, for us, as we've been doing internal experiments, it looks like we're hitting some potential limitations with RAG and looking into what's known as long context models. So instead of only feeding it, the tens of thousands of tokens, you have a world where you could feed it 1 million tokens. And just thinking about that potential of all the data that these models could potentially consume in the future, and figuring out how to balance what's signal versus noise, and trying to peer around the corner of what that can potentially look like. I mean, we don't have visibility to what that can look like, short of the frontier model companies. But just it is very, very exciting to think about that as that potential begins to unlock.
Awesome. And Jason, same question.
Yeah, I'll try to make it fast, but this is super important. This is maybe the most important thing to take away from this talk. Every single year for the last 70 years, since the perceptron came out in 1957, we have had a 4x year-over-year increase in the total amount of compute that has gone into training AI models. And so if we want to skate to where the puck is going to be in a few years, we have to anticipate what a neural network that's 4 times more compute has gone into it a year from now, and 16x more compute has gone into it 2 years from now. And if we think about all of the ways that AI has radically altered the way that things are going. I'm tired of talking about AI as much as the rest of you are. We have these house parties in the Bay Area where people in the industry get together, and we now have these rooms where AI is banned. You're not allowed to talk about AI in the no AI room. But it's not going away. It's going to be much bigger than it is and much more powerful than it is right now. And it's not just hype. 70 years of trend line, and you just look at the trend line and say, where is it going to be? You have to assume it's going to keep going. And everything that I'm seeing is that it is going to keep going. And so if you're planning right now, if you're just starting an AI governance framework, if you're thinking about deployments, if you plan for the models and the chatbots that exist today, and you're not planning for agents and sub-agent architectures and prompt caching environments and all of the things that are emerging on the bleeding edge, you're going to be so far behind. We're on an exponential curve, and an exponential curve is a very, very difficult thing to plan for. And so plan for what a 4x more powerful model is, and plan for what your company does about that. That's the most important thing. Yeah.
You may have just answered my last question, but I'm going to go ahead and pose it anyways. The final question for you both is, if you could send one message about AI security and ethics to every CEO and board member in America, what would it be and why? And how do you think that message would transform the way businesses approach AI adoption and governance? So David, as kind of a final thought here, what is that message that you'd like to give to CEOs and board members?
Please try to invest as much as you are in AI into either those AI safety systems and those risk frameworks and the privacy requirements, and finding ways to adapt to that. Just because there's such a huge push in general, not unique to Instacart, but a huge push for the productivity benefits of what these things can look like, and a lot of excitement. But just because of this gradation of risk that we're faced with, also understanding ways to try to minimize that risk in an effective way.
Awesome. And Jason,
Yeah.
Same question to you. So if you could send one message about AI security and ethics to every CEO and board member in America, what would it be and why? And how do you think that message would transform the way that businesses approach AI adoption and governance?
Intelligence is the most valuable asset in an organization. It's the thing that makes an organization different from a bunch of people running around like chickens with their heads cut off. So if we look at the history of the way these models are going and the projections that I just made, and you sort of look at the first wave of adoption that we're seeing going on in Silicon Valley, right now, I think all of us have seen what I'd call the peanut buttering approach of AI, which is like we have a bunch of products and we're peanut buttering AI on top of everything, right? That is not, it has some incremental value. I think everybody in this room has probably been in a meeting where an AI transcribed all of the words that were said in the Zoom call, and then you got meeting notes that popped out of the end. That's incredibly powerful and useful. Yeah, that's great. And helping you write docs, yes, that's powerful and useful and great. However, the thing that's going to matter is taking a business process and completely automating it. This is not RPA. This is AIs working together as teams to completely subsume an entire business function of course, with human supervision. That is where this is headed. And in that world, an ISO 42K1 or other sort of a trust and safety approach is the bare minimum of the kind of approaches that we're going to be looking at. And chatbots, as the way that things are working right now, is not the way to build a risk model for your company. Yeah.
And so, just a quick follow-up there. You're talking about AI agents taking action. Can you give us maybe an example? Like, what are some of the highest risk?
Yeah. So, I'm a CISO, right? So one of the things that every CISO has to deal with is the tier 1 SOC analyst role, right? So think about a tier 1 SOC analyst. They get an alert that there's been a breach or suspected breach, and now their job is to confirm or deny the hypothesis that there is a breach, right? So there's a workflow. You follow the workflow. You throw an AI agent at it, and it sort of goes and gathers information, and then it uses a bunch of tools that have been given to it. You might maybe go pull HR records or go pull log or document history and sort of understand in this particular context if this person's laptop has been compromised or this production system has been compromised by an intruder. All of those are what I would call workflow or sort of the very beginning of agent-based architectures. However, as models become more powerful, you can just say, you are a tier 1 SOC analyst. Here's the task. Go do the job. You don't have to describe the workflow. You just say, here's all the tools that are available to you. Go do what a person in this role is supposed to do. And if you need to, quote, hire more people to do the job, you can have these other AIs that can spin up that you can delegate tasks to and have them do the work. I think if we think about the future here, and this kind of goes back to Daniel Kahneman's sort of thinking fast and slow. The models that exist today are system 1. System 2 is what's next. So system 2 systems are higher order reasoning, gathering all of this information into a context, bringing the full context of the entire role together and all of the tools and the, quote, team that they have available to them to bring to bear on solving a problem, and that is where we're headed. So yeah, I think that's super important.
Awesome. I think we can end on that note. Thank you both so much. Please give a round of applause to Jason Clinton and David Chow. Thank you for enlightening us.